Let's begin our investigation of Chapter 4, which is all about polynomials. Let's just stop for a second and make sure everyone knows what polynomials mean. Poly means many, and nomials are terms. Okay? Take a look at this polynomial equation. A sub n, x to the n. Now that could be any power. That could be like x to the 9th power, plus a sub n minus 1. That's a different coefficient, and then this would be 9 minus 1, the 8th power, plus x to the 7th power, plus x to the ... first power, and then no x's. So a polynomial can have many terms, as many as you want, and we're not going to start with x squared. We're going to start with way more fancier polynomials, any power you want. Coefficients are real numbers. And what are coefficients? Coefficient is the number in front of a variable. So the coefficients have to be real, but they can be positive or negative or even fractions. Fractions are real, people. The exponents, this is where it gets a little more specific. The exponents have to be non-negative integers. And let's make sure we all understand what that's saying, okay? Non-negative means not negative, okay, but you could be 0. So greater than or equal to 0, just not negative. You could be 0. And then what does integer mean? Integers are whole numbers. They could be positive or negative. No fractions, no decimals. Okay, so in other words, these have to be nice. Okay, the exponents have to be nice. All right, we're going to take a look at some examples here, and we're going to say whether it's a polynomial function or not. Okay, take a look at this. I see x to the 4th. That exponent is nice. The coefficients here are real numbers. Okay, so yes, this is a polynomial. What about this one? Did you know that the radical sign is the power of, good, 1/2? Okay, can you have exponents that are fractions? No. Okay, no, and let's say why. Because the exponent is a fraction. Okay, a polynomial function is x to the 7, to the 6, to the 5, to the 4, not to the 1/2. Let's take a look at this one. I'm going to do a little bit of algebra work here. I'm going to take the quantity x squared minus 2. Put that numerator in parentheses. And if you bring a denominator upstairs, it's going to have the opposite power, -3. So is this a polynomial function? No. And let's say why. Because the exponent is negative. All right, here's some more. What if it's just 0? There's no x's, just one number. Yes, that's a polynomial function. How about if it's an 8? Yes. Okay, these are horizontal lines. Take a look at this one. We could distribute it in. We could FOIL that out. I don't see any fractions or negatives on the exponents. So yes, some people are worried about the negative out in front. You can have a negative coefficient, but we're talking about the exponents. Okay, let's go ahead and write out a polynomial equation. Okay, once again, let's go ahead and remind everyone what a polynomial equation is. This means many terms. Okay, many terms. How are you going to make many terms? Okay, put a big star here. That means you must multiply it out. Some people are great at making the equation, but they don't turn it into a polynomial. So let's go ahead and start with the left-hand side. F of x equals, okay, it's got zeros, 2, -2, and 3, and the degree is 3. Okay, so that means we're going to have 3 sets of parentheses. And the leading coefficient is -1. So the -1 is going to go out in front. That's like your A value. And now we have to put these zeros in. If you told me that the 0 was 2, then you have to write x minus 2. Right? Doesn't that say go 2 to the right and then you get a positive? What if it's -2? Then you'd say x plus 2. And when it says 3, let's go ahead and write x minus 3. Okay, isn't this going to make a degree of 3? X times x times x makes x cubed. But remember, it has to be a polynomial. We have to multiply it out. So let's go ahead and find the easiest way to multiply. Don't forget to write your f of x. Negative 1 I'm just going to save for later. I can't do all 3 at once. It's kind of like saying 2 times 4 times 7. You can't multiply all at once. You have to make 2 times 4 become an 8, and then you could do 2 numbers. So out of these, the easiest thing to do would be to multiply the 2 conjugates, because they make a difference of squares. So go ahead and tell me what x minus 2 times x plus 2 makes. X squared minus 4. Okay, now we have to multiply these two. There's no quick way about it. We're just going to have to get really good at algebra here. So get ready with a nice sharp pencil and a lot of space for this chapter. Let's go ahead and distribute x squared first. Makes x cubed. Outers is going to make minus 3x squared. Inners is going to make minus 4x. And last makes plus 12. Can any of those be added together? Any like terms? No. The final thing, let's distribute in the negative 1. So f of x equals negative x cubed plus 3x squared plus 4x minus 12. There is the polynomial. The degree is 3. Okay, and the leading coefficient is negative 1. The biggest thing I would say is maybe dog-ear this page or something, because the one thing that everyone seems to get wrong by the time we take the test is multiplying it out. Everyone knows how to make it. Yes, you have to multiply, so get really good at it. Okay, let's take a look at even powers and odd powers. So if you have an even power, like 2, 4, 6, okay, we could have f of x equal x to the 4th, or we could have f of x equal x to the 6th. What's going to happen here are the ends are going to go up, up. Okay, now up, up, or taking your hands and going up, up. Okay, that's kind of how people learn, but this is what's happening here. Now, if you have a negative out in front, or if you have negative x to the 6th, or if f of x is negative x to the 10th, okay, it's going to go down, 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 down. Now, it might not look as simple as this parabola. It might have, some more curves or x-intercepts, but the moral of the story is down, down. So where do the ends go? Now, if you are odd, okay, all the odd powers, for example, x cubed, or maybe x to the 7th, anybody with an odd power, the biggest power, you're going to have this end go down, and this one goes up. Down, down, left, up, up, right. So the first end goes down, and this end here goes up. Now, if it's negative and it gets reflected over the x-axis, it goes the other way. This one goes up, and this one's going to go down. Okay, knowing how the ends go are going to really help us when we go to draw our graphs. Okay, now how do you describe end behavior? End behavior means where do the ends go? Where do the ends go? Not necessarily all the good stuff in the middle. So I want you to think down, okay, or up, but you don't write that on the answer line. Okay, so what do you write on a test? You write y equals, you have to put the plus or the minus, and then you write the leading coefficient, okay, and then x to the degree. So what does that look like? Okay, for example, what if it goes down and then up? There might be some fancy stuff in the middle here, but what are we going to write? For example, you would write y equals 7x cubed. So the rest of the polynomial you don't write. Okay, let's describe the end behavior here for this graph. Well, you find the highest power, which is right here. Okay, so the end behavior is positive 4x to the 4th. This is a very fancy polynomial, okay? But what do the ends look like? They look like this. Now, what does this say? This means it goes up and it goes up. Okay, now what we're going to do here is maybe look at a graph. I'm going to look in my calculator, and you can just look with me. So I have a calculator here with f of x as well as y equals 4 to the x. And then they gave us a window. So I'm going to zoom negative 10, 10, scale by 1s. The y-axis, negative 50 to 300, scale by 10s. So let's take a look at the graph here. There's y1. Okay, there's the quartic. Ooh, I'm going to pause it. Okay, so there's the 4x to the 4th. It's kind of curvy down there. Okay, a little fancier, but the ends are going up. Now, I also want to draw this graph. So let's unpause it by hitting enter. Okay, and here comes, oh, there's 4x to the 4th. The ends of the fancy one go the same direction as just the basic 4x to the 4th. Now, it doesn't have all the fancy stuff here, but when you're describing end behavior, you just have to say the number, plus or minus, and the highest power. And that tells you how the ends go. Okay? But what you need to think is up, up. So when you go to draw this, you'll know how to draw it. Okay, graphs of polynomial functions. Okay, this is what a polynomial is. It's smooth. It's continuous. It's curvy. Okay, this is curvy. This is not a polynomial. Okay, this is not, for example, here's a corner, a sharp bend. You cannot have that. This is not. You cannot have a cusp where it goes way high like that. You cannot have a gap. You cannot have a hole. These are not polynomials. This is not what we're studying. Okay, do not draw any of these on your test paper for this chapter. Okay, which of these are polynomials? And if they are, we have to state the degree and the zeros. And if they're not, we have to say why not. So is number A here, is this a polynomial? No. Okay, and the reason is I see a gap. Is this a polynomial? It's pretty smooth and curvy, continuous. Yes. Okay, and the degree of this one is, it's definitely odd. Okay, it's definitely odd, so I'm going to say the degree is 3. Another thing you could do is you could look right there at the turning points. The turning points. There's a turning point right there, and there's a turning point right there. It was going down, then it goes up. So like the maximum minimums. If there's 2 turning points, then the degree is 3. Okay, I think we're maybe not going to see the zeros. We're just going to speed up a little bit. The x-intercepts are there. Is part C a polynomial? No. That looks like a cusp right there. And if you said cusp or corner, that'd be fine. Is this a polynomial? Yes, this is definitely a polynomial. Now let's see if we could figure out the degree. I see down, down. Okay, so we're going to want to say something that's even. But maybe I'll examine the turning points. Could this be degree 2? Is this a parabola? No, it's not a parabola. So since it's not a parabola, right here, we've got 1, 2, 3. There's 3 turning points. Since there's 3 turning points, you're going to have to say an even number a little higher than 2. 1 more than 3 would be 4. Now, you could technically say a 6 or an 8, and that would be correct, but I know I cannot say 2. So some people go just the number right above that, especially since I see 3 turning points. Okay, which of these could possibly be the graph? I'm taking a look at x to the 4th, and I know that it's got to go up, up. Okay, so let's say which ones it's not. Well, it's not D, because that's going down, down. Okay, so now I see these are all even, up, up. And I have to figure out which one could be the 4th. The 4th degree would have how many turning points? 3 turning points. So it cannot be C. That's got way too many curves in there. So that narrows it down to A and B. Now we got to figure out a way to make sure we get the right answer here. And my hint to you would be maybe consider the y-intercept. Survey says it's got to be B because the y-intercept is not positive. So through the process of elimination, knowing about end behavior, knowing about turning points, and y-intercept, you're able to pick the correct graph. Okay, so this whole chapter is going to be polynomials, writing equations, graphing really nice polynomials, and here comes our first one. Okay, we're going to use this polynomial equation right here. We're going to graph it by using all these really cool things. So the first thing we need to do is we need to factor. Okay, so make sure that you're really good at that and you embrace the factoring. f of x equals x to the fourth is going to separate into x squared. Some of you are still using MA tables to do this. Some people are just getting a little better at kind of guessing and checking. Since it's x squared times squared, if you do an MA table, you can just put your numbers right there. So how do you make a 36 but add to 13? And the answers are minus 9, minus 4. Okay, now can that factor any further? Absolutely. So let's go ahead and factor the first difference of squares into x plus 3, x minus 3. The next difference of squares is x plus 2, x minus 2. And so I see my degree of 4 is going to have 4 x-intercepts. So let's find the zeros or the roots or the x-intercepts. So we've got plus and minus 3 comma 0 and plus and minus 2 comma 0. Okay, so on a graph, maybe I'll just kind of get this ready. 1, 2, 3. 1, 2, 3. Positive 3, positive 2, negative 2, and negative 3. Okay, how about a y-intercept? The y-intercept is a lot easier if you go back to the original polynomial. To find a y-intercept, you put 0 in for x, 0 for x, 0 for x, and you get that constant right there, 36. So now I'm going to go over here to my graph. On the y-axis, I'm just going to go up yay far, put a tick mark, and label it 36. Don't feel like you have to put 36 tick marks. As long as you put the number, we'll be all good. Okay, now, end behavior. I'm looking at the original polynomial here, and it's x to the fourth. So the official answer is y equals 1, leading coefficient 1, x to the fourth. Now that's what you put on the answer line. But a lot of people like to think, they think up, up. That's not an answer for the math test. That's what you put, but this is what you got to think. So over here, we're going to put an up and an up. Okay, now we have to graph the polynomial with this much information. Okay, so I know the polynomial has to come down this way. And I know it has that x-intercept. Now where are we going to go? How about we touch this x-axis? Touch that x-intercept. Okay, can I come down and touch negative 1? No, it doesn't have that as an x-intercept. So maybe what I'll do is come here and touch this y-intercept. Okay, now I got to come back down because I got a couple more intercepts here. Go touch this point. Make sure you touch it 3 and make sure, does it come back down? No, there's no more x-intercepts, and I know I got to go up, so my graph's going to go up, up. So you just drew your first polynomial equation there, your first x to the fourth, okay, by hand. All right, let's go through a couple more. Find the zeros, the roots, all this stuff so we could draw a nice graph. Okay, well, to do this, we're going to have to get really good at factoring, right? The first thing I will do is maybe take out any constant or any monomial that you can. Since they all have an x, I'll definitely take out an x. And I'll factor out the negative because factoring is easier if that leading term is positive. So take the negative x out. He'll have positive, and how many x's left? 2 x's. This was a positive. I took away negative, so it's negative. I took away one of his x's. That's 2x. Positive divided by negative is going to be negative. I factored out his x. Now all he has is a 24. Okay, let's do some more factoring. Don't forget to write f of x equals. We've got a negative x right there. X squared factors into x and x. So we're trying to figure out how to make a negative 24, but add to a 2. So 2 numbers apart. So we're going to have to do a 6 times 4. And who is going to get the negative? The 6 will. Okay, let's just double check. X squared plus 4x minus 6x, good? Minus 24. Yes, it works. You got it factored. If you don't factor it, everything else becomes wrong. Finding the zeros. Okay, so we're going to look for the x's. Now here's an x, and that gives us an answer. Here, let me show you. Negative x equals 0. Divide by negative, and we get 0, comma 0. If I manually do that for all of them, x minus 6 equals 0. Add 6 to their side, and you get 6, comma 0. X plus 4 equals 0, and we get negative 4, comma 0. Okay, some people are wondering, well, how come if there's a 5 out there you don't get an answer? Well, you don't say 5 equals 0 because it doesn't. It's only when there's x's. X to the third could have at most 3 x-intercepts. It doesn't have to have 3, but it could have 3 at most. So let's put some points at 0, 0. I'm going to put one at 6, 0. And as long as I put a number there, or you could put 6 tick marks, but putting a number for sure, just so that I can grade it quickly. -4 right there. Okay, x-intercepts are done. Now it's time for the y-intercept. The easiest place to look for the y-intercept is the original equation. 0, 0, 0. Oh, we're getting 0. Okay, y-intercept, you let x equal 0. And, oh, I already have the y-intercept. So here's a little hint. If your x-intercept is 0, 0, that's also going to be your y-intercept. Okay, let's describe the end behavior the correct way. The equation is y equals, go to the polynomial and state positive or negative, in this case negative, and then the leading coefficient is 1, and the highest degree is x cubed. Now that's what you write, but what does a negative x cubed look like? It doesn't look like a regular x cubed reflected over the x-axis, and it's going to look like this. Now there might be some more stuff in the middle, but that's what happens on the ends. Okay, so let's just put the ends here. Got to put the end here like this, and the end here like this. Okay, those are all your hints. Now it's like a little puzzle. So let's put your pencil up here. The graph comes down, down, down. Touch right there at that intercept. Okay, we're going to cross this x-intercept and that x-intercept. Now, whenever you're doing these little puzzles, if something's not working and your end behaviors there, don't just go up there and cross the x-axis in a wrong point. Try to figure out what went wrong. Okay, all of these graphs need to be done by hand without a calculator. This last one right here I've already factored for you, so that's really easy. Okay, -2 is not an x, so that's not an x-intercept. The first one is going to be -5, 0. -1, 0, +2, 0, and 6, 0. So let's go ahead and get these on the graph. 2 and 6. Go ahead and put your points on it. -1 right there, and -5. Okay, make sure you put numbers and put some nice clear points. Put some nice dark points for me to grade. The y-intercept. Okay, y-intercept, you let x equal 0. Okay, so it's going to be 0, something. Now, since I factored it for you, that was really easy, but now we're going to have to actually calculate the y-intercept. So if you put 0 in for x, that's going to be -2, 0 plus 5 is 5, 0 plus 1 is 1, that's going to be -2, -6. I put 0 in for x. Now you have to calculate this. -10 times 12, -120. -120. So on the y-axis, we're going to go down to -120, maybe right there. Okay. Again, it's not to scale, or maybe my scale went by tens or something. Describe the end behavior. Y equals, what's the leading coefficient? Definitely -2. Now, I don't feel like multiplying all this out. If I did multiply it out, do you know what the highest degree of x would be? X times x times x times x. It would be x to the 4th. So just kind of think about how many x's there are without actually multiplying it all out. The end behavior would be like that. Okay. So what do the ends look like? Even goes the same way. So is it up, up, or down, down? Since it's negative, it's going to be going down, down. Okay, ready? Puzzle time. This goes up, 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 crosses x-intercept, x-intercept. Go grab that y-intercept, x-intercept, x-intercept. Okay, these are going to be kind of fun. I can determine if an equation is a polynomial or not. The exponents have to be nice. I can write an equation, okay, of a polynomial. Okay, make sure that you multiply it out. Multiply it out. I can determine the end behavior. Okay, so that's going to be y equals plus minus, I don't know, 7x cubed, whatever it is. I can determine a graph is a polynomial. No cusps, no gaps, smooth and curvy. I can graph a polynomial after I get all the information. I sure hope you can.